Hello students, Eric Magidson here. I'm going to be your guide through Module 1, Impact of Digital Technology for Computer Concepts courses. So here we go. We'll just jump right into the material. Let's take a quick look at our lesson objectives. Now our lesson objectives are as follows. We're going to look at, and I'm going to explain to you the evolution of society's reliance on technology. And of course, we don't have to go very far back, just a couple generations back, to realize that things that used to be done on pen and paper are now definitely done on computer. Phones have changed, technology has changed, and there's a huge impact on our life. We're going to look at developing personal uses for technology to help with productivity and learning and future career growth. Of course, obviously, there's careers that exist today that didn't exist just 5 years ago as it pertains to computers and technology. And then finally, we'll look at explaining the role of technology in the professional world. So, of course, you're in an education environment, you're here to get a degree, and I guarantee technology is going to be a part of your requirement as you work through your degree, not only to do the courses, but also within your professional career. So the first section that we'll look at, the evolution of reliance on technology. We're going to briefly introduce you to the history of computers. Important to understand where we came from. We'll look at the most popular thing right now, which is Internet of Things. We're talking about 20 billion devices connected by this year, on an estimate, connected to the internet that are Internet of Things devices. Discover uses for artificial intelligence, and then of course, virtual reality as well. So when we first started out with computers, we started out with vacuum tubes. Now these are the computers that you might think of that took up the entire room. Now before we do that, you can look down here at just the basic evolution of the Apple computer and how far it's come since 1976 through to 2009. And of course, we've seen huge impacts since as the technology continues to increase. So let's take a look real quick. Our first generation used vacuum tubes. So these are the vacuum tubes that they used. This is where data was stored, the logic, the ones and zeros. Now we need to understand that computers, digital technology, only understands two things, ones and zeros. Let's go to the next one. This starts looking more like what you're used to seeing for computers. Now, let's be careful here. Those vacuum tubes were replaced by transistors on a circuit board. But the thing was, each of these transistors did independent things, whereas what we needed was a single device that could do everything, that could do the logic, that could do the math, that could do the Boolean logic of true and false, all of those things. And so consequently, like with any developing technology, it started getting smaller, it started getting less expensive, and it started getting more powerful. So let's take a look here at the last one. So integrated circuits. So we went from these transistors into a single integrated circuit. Now, of course, these still fit on a motherboard, and the motherboard has the technology that's needed to understand what this is. So this is our first look at what's called a processor. Now these used to be big, and when we looked at putting two of these on the same motherboard, we had dual processors. So let's not confuse that with what I'm about to show you. This is a single processor. These started out, with 8 bits and then 16 bits that they could process at a time, up to 32 bits, and then what's common today, which is 64-bit technology, meaning that these processors can process 64 ones and zeros with each cycle. That brought us up to the microprocessor. As we got to this, folks, what we ended up doing is increasing the speed. You see that this is an older i7. They now make i9s. But what we started to do with microprocessors is put multiple microprocessors and multiple central processing units onto the same integrated circuit. So consequently, like this one here, this might be a dual core, not to be confused with putting 2 microprocessors on a motherboard, but this actually has embedded in it 2 independent microprocessors that work together in conjunction. That would be a dual core. Then we went to 4 cores on a single microprocessor. Of course, this is more modern than 1971. But what we ended up with was 4, and then we went to 6, and now we're at 8. So the computer that I'm looking to buy now is an Intel Core i9. It has 8 processors, each processing 64 bits per cycle. Cycles now are up to the gigahertz, giga being billion, so billions of processes per second. Let's look at Internet of Things. So what did we do with all this processing power, with these inner processors and everything else? Well, as those processors started to get smaller, we could create independent computing devices that did specific jobs or specific functions. And then, of course, connect those to the internet. So when we talk about Internet of Things, processors are embedded in many products, smart devices, which communicate via internet or wireless. And then, of course, embedded computers. And today, we see this idea of Internet of Things and embedded computers almost becoming one. And I'll show you what I mean here. So here we have a Nest thermostat that you would put in your home. You're able to use your smartphone to set a schedule that works. It also has some intelligence built in, meaning if it doesn't see activity in the room that it's in, and you could also get sensors for other rooms as well, it won't heat the house, because why heat the house if there's no activity? So we can set it, we can look at our cost for electricity or gas or whatever it is, how many units we're using, and it connects to the internet so that both Nest can get data on it, and of course we can get data through our cell phones. Another example of Internet of Things devices are security cameras. Here's an example of wireless. This is the Netgear Arlo system. So literally without running wires and frankly without running power, because these are battery powered, we just need to pull the batteries about every 6 months, we can put security cameras around our house. Now these are just 2 of the common things that we use, but today we have smart bulbs that connect via the internet so we can turn them on and off, create schedules. We can also use them with our home devices like our Alexa or our Google Hub to create schedules, to touch when we want something on and off, or just simply say, okay, G. Now I have to say, okay, G, because my phone's right next to me. And if I say the whole thing, it's going to say, hey, Eric, what do you need help with? So consequently, we have lights. We even have smart washers, smart refrigerators. We definitely have our smart watches. We'll look at those a little bit more in just a few minutes. ATMs, example of embedded computers. So there's a computer in there. And if you're not aware, in your smartphone, in your smart TV is an embedded computer. So through your smart TV, you can get to Netflix, you can shop on Amazon, you can watch YouTube and Hulu. All of these are now built into the TV, when before you might have to get a DVD that had these things built in, or a Blu-ray player, for example. Where did all this go? Well, it quickly evolved into artificial intelligence. Now, be careful as you think of artificial intelligence in the fact that these are still computing devices that have been programmed, to think. So, the technological use of logic or prior experience to simulate human intelligence. That's what we're talking about. So if you think about it, a decision that you make today could potentially be based on everything that's happened in your life previously. Okay? For example, we know we're not going to touch a hot stove, and we know that because as a child, we gained intelligence that the stove was hot. Maybe we even had to burn ourselves to do that. Capabilities for artificial intelligence, speech recognition. I remember watching Star Trek when I was a kid. Captain Kirk would speak to the computer, and I thought, that's never going to happen in my lifetime. And now, of course, I can speak to my Google Home. I can tell it to change the temperature through the Nest in my house. I can speak to my phone. I can send a text, voice to text, or even text to voice, where my Google phone will read me my last text messages. We'll look at virtual reality, logical reasoning and creative responses, which are a little bit different. So as we talk about virtual reality here, We're talking about the use of computers to simulate a real or imagined environment. So, of course, we look at it, this can literally be a real environment that exists that I'm not in. For example, rainforests or mountains or whatever. And I can go ahead and utilize virtual reality to be there, to run in the forest, for example. Okay, someone here looking at their VR goggles, who knows what they're seeing. And of course, let's just not look at this from an entertainment standpoint. We are starting to see virtual reality come into medical, for example, where, for example, a brain surgeon now is going to conduct the surgery from outside the operating room, while robotic arms who have much more precision than the doctor herself does. So she's actually working the arms, if you will, through a virtual or augmented reality where it's an actual space. Things are actually exist. It's not just this artificial digital world that we think of when we think of VR or gameplay within that arena. So we'll go ahead and stop here. We'll cover the next section, personal uses for technology, in the next video. See you then.